Okay, so here is the circuit we've been talking about in class, the D to A converter circuit that uses a PIC microcontroller and TLC 72 op amp. Here's the op amp, here's the PIC microcontroller. This is the capacitor that we talked about that's being integrated with. Here's one part of the voltage divider, the square wave coming out of the PIC microcontroller comes up through the voltage divider. This is the other side of the voltage divider, and a reduced size square wave is then used to control the current through this resistor here, that then charges the capacitor. This is the power MOSFET that we're using as a switch to discharge the capacitor at the end of the cycle to start a new integration. So we have some probes hooked up. We have one hooked up to the square wave being generated by the PIC microcontroller to be integrated, and we're using that to trigger the oscilloscope. And we have another one hooked up to a buffered output from the capacitor. So it goes through a buffer amplifier that we hooked up here to look at the value on the capacitor. So let's go look at the scope and see these signals. And here we can see, go get the door, the square wave coming out of the oscilloscope that is used for integration, and you can see as the square wave goes high, the integration cycle starts and we integrate up. Here's the reset pulse, here's the reset of the signal, and you see at the end of this pulse here, the reset happening, and in this case you can see that the integration is going from 0 volts up to 4 volts. We have the cursor set on the second trace for 4 volts. Here it is 4 volts. And if you look at, we have the X cursor set to measure the time of the integration period, and you can see we have it set for 64 milliseconds. So 64 milliseconds is going to 4 volts. So now my assistant's going to change the value that says 64. Here's the 64 in the program. We're going to change this to 32 down here, hopefully. Right, 32, and then reload the software. You see it reloading. If you look, you see this, the thing has stopped working, and hopefully it will restart. There, it restarted, and now we see that it's going to this different cursor level, which I've set for 2 volts, and it's taking about half the time to integrate that it was before. So we have effectively a 64 to 2 volt D to A converter that we've built, and by changing the numerical value that we pause for in the program, we can change the D to A converted value.